Hello. In this video we're looking at MEI FP2, the January 2011 paper, question 4, which is on hyperbolic functions. It's a long question, so read the whole question through first. The first part asks us to solve the equation, and note that it says express your answer in exact logarithmic form. We're then given the equation of a curve, and it says using part 1 or otherwise. Well, generally speaking, it's advisable to use part 1 because it's going to be easier and quicker. Find in exact form the coordinates of the points on the curve at which the gradient is 16. Then it says show that there is no point on the curve at which the gradient is 0. And using all of that information, we'll need to sketch the curve. Finally, we've got to find, again in exact form, the positive value of A, for which the area of the region between the curve, the x-axis and the y-axis, and the line x equals A, is a half. Okay, part 1. We've got sinh and cosh, no squares, so our best bet is going to be to go straight into the exponential form. So sinh t plus cosh t equals 8, a half e to the t minus e to the minus t plus 7 over 2 e to the t plus e to the minus t equals 8. So multiplying through by 2, e to the t minus e to the minus t plus 7 e to the t plus 7 e to the minus t equals 16. So 8 e to the t minus 16 plus 6 e to the minus t equals 0. And if I multiply through by e to the t, I will get a quadratic in e to the t. So 8 e to the t minus 16 e to the t plus 6 equals 0. I can see that now I want to divide through by 2. And I can now factorise this. 2e to the t minus 3, 2e to the t minus 1. So e to the t is either equal to 3 over 2, or e to the t is a half, from which we get that t is equal to log of 3 over 2, or t is equal to log of a half. Then we've got that equation, and we're looking for the points on the curve at which the gradient is 16. Well, the first thing we need to do then is to differentiate. Y equals cosh 2x plus 7 sinh 2x means that dy by dx using the chain rule is 2 sinh 2x plus 14 cosh 2x. And we want that to be equal to 16. So that means that sinh 2x plus 7 cosh 2x equals 8. And that's almost what we had to start with on the previous slide. We just had t instead of 2x. So where t was equal to log of 3 over 2, I've now got that 2x is equal to natural log of 3 over 2, or 2x is equal to the natural log of a half, and therefore that x is a half log 3 over 2, or x is a half log a half. So there are my x coordinates, but of course I need the y coordinates as well. So if x is a half log 3 over 2, then y is cosh of log 3 over 2 plus 7 sinh of log 3 over 2, which is 13 over 12 plus 7 lots of 5 over 12, and that's equal to 4. So that gives me the point a half log 3 over 2, 4. And using the other value of x, if x is a half log a half, then y is cosh log a half plus sinh log a half. You can just do these on a calculator. You can work it out, but using the exponential form, but you can also just plug it into your calculator. 5/4 plus 7 lots of -3/4, which is equal to -4. And that gives the other point being a half log a half -4. We're then asked to show that there is no point on the curve at which the gradient is 0. So let's see what happens if we take the gradient to be 0. dy by dx equals 0 implies that what we have for the derivative, which was 2 sinh 2x plus 14 cosh 2x, is equal to 0. That would mean that sinh 2x was equal to -7 cosh 2x, and dividing by cosh 2x, that would give us tanch 2x equals -7. But we know that tanch has to be between -1 and 1, so there are no solutions since -1 is less than tanch 2x less than 1 for all x. Now we can do our sketch. We're trying to sketch y equals cosh 2x plus 7 sinh 2x. And we can see that if x is 0, then y is equal to 1. We know that there are no places where the gradient is 0. The sinh term is going to take over from the cosh term because there's 7 of them, so it's going to look something like this. Going through the point 1. Now, find in exact form the positive value of A for which the area of the region between the curve, the x-axis, the y-axis and the line x equals A is a half. Let's look back at our sketch and see where that will be. It's a positive value of A, and it's this area here. So that is just the integral from 0 to A of my curve cosh 2x plus 7 sinh 2x dx, and we want that to be a half. So doing the integration, we get a half sinh 2x plus 7 over 2 cosh 2x between 0 and A. Then we need to substitute in. So a half sinh 2a plus 7 over 2 cosh 2a minus, if x is 0, then sinh x is 0, and if cosh is 0, then, sorry, if 2x is 0, then cosh of 0 is 1. So that's plus 7. So multiplying through by 2, I get sinh 2a plus 7 cosh 2a equals 8. Should have been a 7 over 2 there. So this is the same equation we had before. I get a equals a half log a half, or a equals a half log 3 over 2. That would be a negative number, and we're asked for a positive one. So I get a equals a half log 3 over 2. Let's see how the mark scheme works for this question. For part 1, there's a method mark for substituting the correct exponential forms. There's then another method mark for getting down to a quadratic in e to the t. There's a method mark for getting at least one value of e to the t, and accuracy marks for getting these two correct. And then there's another accuracy mark for getting the final answers for t, correct only, answer only, or equivalent exact form. For part 2, there's a single mark for correctly doing the differentiation. There's then a method mark for a complete method to obtain an x value, and an accuracy mark for getting both x coordinates in any exact form. There's then a single mark for getting both of the y coordinates correct from your x coordinates. For the points showing that there are no points where the gradient is 0, there is a method mark for any complete method and an accuracy mark for a convincing argument, bearing in mind that you are told that there are no points. For the sketch, there's one mark for a curve, the correct general shape, and a positive gradient throughout. So in other words, noting that there were no 0 gradient points. And another mark for going through the point 0, 1, but it's dependent on the previous mark. And finally, a method mark for attempting the integration and an accuracy mark for doing it correctly. A method mark for using the limits and getting a complete method to a value for a, and an accuracy mark for getting a final answer of a half log 3 over 2, and you must clearly reject the solution a equals a half log a half, but you don't have to give a reason in order to get the mark. If you want to find videos of other questions on this unit or on other units, please visit the Further Maths Support Programme's website. Goodbye.